Now, how about the energy needed to go up hills? The road to Sydney is very far from being flat. Well, in principle, let's say this is the road, there's Canberra, and you go up a hill, and then down a hill, and then up a hill, and then down a hill, and up and down, and eventually you end up a bit lower than where you started. What you could do is just take the starting height, about sea level, and the end height, and look at the difference. That could be delta H, the difference in height, and then work out the potential energy. So the potential energy will be mg times delta H, and because Sydney is lower altitude than Canberra, the potential energy is lower down here, so actually the amount of energy needed to go to Sydney is negative. So it's helping you. But that doesn't really seem to make sense, because I know if I am going for a bike ride and my path looks like this, even though I'm ending up lower than I started, that's going to be hard work. Whereas if the path just looked like this, I'm ending at the same height, but that's going to be much easier. So what's going on here? Well, in principle, if you're driving up a hill, you need to put in energy to get to the top of the hill, and then you don't need energy to come down. In fact, the reverse. The hill will power you on the way down, and then it's positive energy, negative energy, positive energy, negative energy. So if there was no friction, you need to put enough energy to get up here, and then you could probably just roller coaster the rest of the way down. In practice, that won't work. Well, might work partially. I mean, certainly when you're on a downhill, you could ease off on the accelerator and still your car will go fairly fast, so it's helping you there. If you're walking, on the other hand, you don't really get back energy walking downhill compared to going uphill. So it's a bit complicated. How much energy from the uphills we get back going down. So let's do a simple model. Let's just assume we have to put work in to go up, and we gain nothing from going downhill. Almost certainly reality will be better than that, but that'll do as a first estimate. It'll give us an overestimate of how much power is needed. So let's say we have a particular hill, and let's say it's about 100 meters high. Energy needed to climb that is just mgh. So we said 1,500 kilograms for our car times g, which will approximate as 10 times 100 meters. So that comes out as to the 2, 3, 4, 5, 6, roughly 10 to the 6 joules. So that's about the same as the energy needed to accelerate up to 100 kilometers an hour, and 100 times less than either the rolling resistance or the drag. Now that's just one hill. There might be several hills. In fact, there are on the way to Sydney. But let's say there are 10 hills. It's still only 10 to the 7 joules. It's still 10 times less than the rolling resistance for the drag. So by and large, hill climbing is, in this particular situation, probably not worth worrying about too much. It's much smaller than other effects.